Good morning. My name is Rick Torres, Applications Engineer for Circular Refinery Valves. Today we're going to be discussing DeltaValve's unique and robust solution on severe service application isolation valves for the delayed coker. Let's go right ahead. DeltaValve has a lot of experience on the delayed coker with over 1,000+ units sold in the bottom and top unheading market. We've also innovated the use of a center feed injection device to centralize the flow up the drum and equalize uniform temperature distribution around the drum. But one of our little or lesser known products is the use of our sliding gate technology for isolation valves. So DeltaValve's flagship product is the bottom unheading device, which utilizes this sliding gate technology in double block and purge. The use of this technology has proven to be very robust in this environment in the sense that it can deal with this solids latent service a lot more reliably than wedge or ball plug valves in this service. So it only seemed natural to evolve the technology into the isolation valves. Now, the great thing about this bottom unheading and top unheading valves is that they've undergone millions of cycles at 100+ refineries in 20+ countries without any loss of containment or any safety incidents. And that is in a more severe service. So let's talk a little bit more about the isolation valve technology and how it compares to the bottom unheading valve. And first off, we're going to talk about the operational challenges that are facing the DCU with the use of a ball and wedge plug type valves. So first and foremost, these ball valves and wedge plug valves utilize a lot of steam. Now, all valves, whether it be the DeltaValve isolation valves or any other wedge and ball plug valve in this service, are rated for and tested for leakage per API 598. The problem with ball and wedge plug valves is that over time, this leakage rate increases significantly, and the thrust required to keep them sealed also increases significantly. And this can be caused and is caused by simple upset conditions in the unit or loss of purge steam to the body cavity on the valves. The issue with these valves is once the seating components, whether it be the ball, wedge, or the seats in the body, become contaminated or coke gets around the seats, there is no effective way to clean that material out of the seat components. And we'll show how DeltaValve's technology solution improves upon that. The next is high installation and operational costs. So because these valves generally have a lot more steam ports and utilize a lot more steam, their installation and operational costs tend to be much more significant than the DeltaValve solution. And the high cost of maintenance and repair. So being that the isolation valve technology stemmed from the unheading valve technology, there is no valve in the delayed coker that sees a more severe service than the bottom unheading valve. The bottom unheading valve sees the resid at temperature, and then also sees obviously the lower extremes of temperatures in terms of water and steam, but then also has to deal with the flowing of hard coke through the orifice of the valve. And so the bottom unheading valve sees the most severe service in the delayed coker. Well, the isolation valve is based off of the same technology as the bottom unheading valve, except in some of the more or less severe applications, such as the overhead vapor and even in the feed line. Now, what this translates to is because it is not as severe a service as the bottom unheading valve, the operational life of our isolation valves is greatly extended. And you'll see in the coming slides where we have many installations that have used the unheading valves for multiple turnarounds without the need of any maintenance whatsoever. So, next slide here. So how does the bottom unheading valve or the isolation valve compare to the bottom unheading valve? Well, the isolation valve has been around since 2007. The bottom unheading valve was installed first in the Chevron Salt Lake City refinery in 2001. Both utilize the dual metal live loaded seats. The technology that it uses is the double block and purge technology. Now, the main difference between the two technologies is really the orientation that the valve can be placed in. Where the bottom unheading valve is always at the bottom of the coke drum and in this horizontal orientation, the isolation valve can be placed in any orientation. It is also a bidirectional valve, as opposed to the bottom unheading valve that only flows in one direction. The isolation valve seals in both directions. So, a quick design overview. The valve is available from 6 to 54 inches plus. It utilizes that double block and purge isolation. And here's the really interesting part is the static purge for ultra low steam consumption numbers are on average 2 kilograms per inch per hour per inch of diameter. So a 10 inch valve would consume approximately 20 kilograms per hour. That's how that works. They are tested per API 598, fully bidirectional. One of the key aspects of why this valve is so reliable in service is this dual live loaded self-cleaning metal seats. And that is very important because our valve seats never lose contact with the sliding gate. Every time the gate moves from the open to the close or vice versa, the seats will clean the gate and the gate will clean the seats. And so you'll have a nice, clean, sealing, uniform sealing surface every time the valve moves into the fully closed or the fully open position. And that's how the unheading valves work. But that's how we were able to maintain a really low steam consumption on these valves over time. One other really neat feature about these valves is that they are fully inline serviceable. Now, what does that mean? That means that you can replace all of the internals of the valve, including the seats and the gate, by simply removing the upper bonnet, even with the actuator attached. And that can be done with the valve in the line. The valve comes in a B16.10 flange-to-flange configuration to replace any existing ball or wedge-plug valves that you have in service. However, the valve is also able to be reduced to the smallest footprint on a face-to-face in the industry. So that is very similar to the bottom unheading valve as well. The valve model that we're going to be discussing is the GV852, which is the sealed body cavity valve with extended seat plates. And we'll go to the next slide where we show the comparison between the way that the double block and purge technology works on the bottom unheading valve, where you have two seats with a purge media in the body. And in order for the process to escape, it has to get past the first seat, pressurize the second or the body cavity, and then escape out the bottom seat. And that has never occurred. And so we take this on its side and we're able to show how this works on the isolation valve. And it's very similar. As you can see, there is a sliding disc with two seats, and the pressure comes from one side, and the steam purge pressure that is 1 bar above the process pressure is used as a secondary seal. The GV852 sealed body cavity is different than other sliding gate valves in the sense that DeltaValve has extended the seat plates into the body cavity such that the gate and the orifice of the gate are completely isolated from the body throughout the entire stroke. Even in the intermittent position, as you can see in the picture in the middle, you can see that the orifice is sandwiched in between these two extended seat plates. And what that means is as the valve moves from the open to the closed position or to the isolated position, the process media is trapped in this area, in the orifice area. That process media will condense and it may solidify, but it will not escape into the valve body cavity, and the valve body cavity will remain clean. And so when the valve extends back into the open position, that process will then be freed into the process pipe, and the body cavity will remain clean. And this ensures that the valve, one, functions properly, is able to stroke every cycle, but two, that it maintains a low steam consumption because you're not worried about the body being contaminated and affecting the performance of the valve. This is recommended for any of the overhead service. It's also recommended for drain to coke, any wax tailings, anything that really is in contact with hydrocarbons is recommended to use the GV852 sealed body cavity valve. So behind the DeltaValve success is really the innovative design of our seating technology. And DeltaValve first came to market on the bottom unheading valve. The use of this double block and purge technology in conjunction with seats that were designed for the delayed coker service and such that they could be used reliably throughout one turnaround to another. And that was unheard of for slide gate valves in the past. Now, we have continued to evolve and to improve our seats. And one of the latest improvements that we've accomplished with the seat technology is the use of a welded Inconel bellows between the seat components, eliminating any leak path between the seats and the process. So there's no longer a need to worry about the seat components leaking steam into the process, or that process will leak by the seats into the steam cavity. Now, the only leak path available for process or for steam occurs between the interaction on the gate and the seat. And that is very, very beneficial. What we found is we can then take the seat, utilize it, and it will be reliably sealing for many, many cycles, including multiple turnaround cycles. We have valves that have been in service for 15 years without replacing any of these seat components. Steam port comparisons. So one of the nice things about the DeltaValve isolation valve is that it's one single pressure cavity. So as a result, you only need one steam port injection, and that pressurizes the entire body cavity. On ball and some wedge plugs, you have to have multiple steam port injections to ensure that the valve operates correctly. And this is one of the main components where there is an opportunity for cost savings, because this reduces the piping cost. It's lower engineering costs for the piping layouts and lower amount of fixtures, joints, and supports. And so this has the capability of proving some really nice savings for the refinery. So as we spoke about earlier, the DeltaValve isolation valve is based off of the bottom and top unheading valve technologies. Now, these isolation valves were placed in series as two valves for one line to achieve the required isolation requirements. So the problem with that is that, well, you have two valves doing the same job. And sometimes that's a double ball valve configuration or a ball and a gate valve configuration. But the fact remains that you have two valves, two MOVs, two steam port injections into the system. Now, the bottom unheading valve has been seating reliably for nearly 20 years, as we talked about, 2 million cycles combined across the fleet with no loss of containment incidents in a more severe service. And so now the push, and it has been accepted by various refineries in the US, is to remove one of these valves from the line and utilize a single DeltaValve isolation valve with double block and purge technology in place of two ball or two valves in that same line. And this gives you the same reliability, and it removes obviously the capital expense of one of the valves, but all the maintenance associated with multiple valves and the maintenance associated with these valves, because those valves have to be serviced every turnaround. And the DeltaValve is capable of achieving multiple turnarounds on a single valve internals. So this is the isolation valve video. I will not go through the entire video. I'll let you view that on a separate time. It's very nice. It shows how the seating technology works as the valve is in line. And so I'll only go through the first 30 seconds or so, where it shows how the double block and purge technology works and how the scraping of the seats against the gate works to serve, to show or to provide a nice cleaning service every time. And so as you can see, the process is trapped at the bottom in the yellow. And as the valve moves back and forth from the open to closed position, the process is isolated and the steam is isolated from the process as well. And so that serves to keep a nice clean body cavity and will allow the valve to function for a lot longer service life compared to other valves in this service. So the valves that we have in the delayed coker, first and foremost, we're looking at the bottom and top unheading valves plus the center feed device. Those are the common valves that are seen on the delayed coker. But then we have the back warming isolation valve. And I really want to take a minute to talk about this valve because this valve is typically seen as a pinch valve for the unit. It is not seen as an isolation valve. Well, as with the GV852 extended seat or sealed body cavity technology, this valve can now function as both a throttling valve application and an isolation valve application. So we have various customers that have utilized this valve and are very happy with the valve and the performance because it offers the additional functionality of a isolation valve with the normal function of a pinch valve or a back warming valve. We have the atmospheric vent application, the PSV outlet isolation valves, the overhead vapor to fractionator isolation valve, the coke drum bypass valve, the feed isolation valve, and the main utility header isolation valve. These are the severe service valves that DeltaValve has noted that have the most amount of problems on the delayed coker. And so these are the valves that we are targeting for replacement in this market. The pressures and temperatures at the bottom are typical 70 PSI at 920, but any service can be met. The top is 805 at 20 PSI, typical. Now, one of the things that you'll notice on this graph is that the valves on the overhead lines are duplicated on the left and are not on the right. And so this is just to show a schematic of both configurations with the legacy duplication of the overhead valves on the left and the DeltaValve isolation with a single valve with double block and purge on the right. The valve also features some really robust design features. The integrated travel limit stops, the coupling skirt provides a full closed stop, and the back seat provides a full open stop. And really these are not adjustable and they're tamper-proof. Additionally, the valve will not stroke without the coupling. Another advanced feature is the advanced stem coupling that is integrated into this valve. The shear pins unbolt and are removed whenever a broken pin occurs. However, the upper shear pin is designed to be the weakest link and is designed for 3.5 times safety factor. One of the last slides that I want to talk about is this operational performance letter that was given to us by Chevron. This letter is dated back in 2014, but one of the things that you'll note is that in 2008, they replaced some, actually 2 valves in series on their overhead lines, a 12-inch, a 14, and a 16-inch, and those were both, so 2 12-inch, 2 14-inch, and 2 16-inches. And they replaced them in 2008 because they were having the typical troubles that people have with the overhead line valves. And those valves performed for 4 years, and in 2012, after 4 years of maintenance-free operation, they decided to do some inspection and leave those valves back in service, and those were going to be inspected again in 2017. Obviously, 2017 has come and gone. Those valves were inspected once again in 2017, and left again for service without any replacement of major components. The only service that has been performed on those valves has been the tightening and or replacement of the stem packing. But that is very minor service that is performed on these valves. Overall, the valves have performed exceptionally well, as you can see on steam trends on the next page. And that is really key to see. These purple and orange lines represent a group of 3 valves. So a 12-inch, a 14, and a 16-inch consumption is shown by each line, one purple and one orange. One of the interesting things to note about this graph is that it reads right to left. So the oldest year on the right and the newest year is on the left. And so what we have here is a 4-year steam trend for a valve, and the valve is consuming the same amount of steam, and it's about 150 to 180 pounds per hour for a group of 3 valves. So at worst, the valves are performing at 5 kilograms per hour, or sorry, 5 pounds per hour of steam consumption. And so that is remarkably low for valves of this type in this industry. And the valves have continued to operate at this level, and the valves have been in operation now for over 12 years and are still operating with this low steam consumption number. So once again, the features that should be noted on this isolation valve is that technology has been proven since 2008. We have over 150 plus units in use. They are notoriously well at providing a low steam consumption and a reliable steam consumption. They are inline serviceable and will lower your operational and installation costs. Please feel free to approach me with any questions, and I'll be glad to answer. Thank you.